Welcome back. So this is the method to initialize the population. We will use it in this method called runGA, and the idea here is to loop through the population that we created here, and then each element we just randomize the elements of this initial chromosome, right? This shuffle int array method, we've seen it here in the utility class. This is what we use to randomize the elements of this array, right? I should say here, I should add the parameter it receives and what it returns. I'll do that later, right? But this is the method that does the shuffling or the randomization. So this is how we start the initial population. This method is used to find the fittest member of the population. Fittest member is the one with the highest population so far, right? And then evolve population, we've seen this method before in the previous videos, so I'm going to skip explaining it here again. And the selection using the roulette wheel, we've seen this before again, so let's skip it and go to the runGA. This is where we start. In the beginning we initialize the population randomly by calling this method called init population. We've seen that, and then we loop the number of times, the maximum number of tours. As we said, we declare it here as to be 3000. What we do here, I just print out the current tournament number to keep track of how many tournaments, and then I just try to find the fittest member of the current population, right, as I explained previously. And I check the fitness now of this population member. If it's 9, then we found the solution. We just display the results using the display method, and we found the solution true, so we can exit. Otherwise, we keep track of the best solution so far. So we say if the fitness of the fittest member of this population is larger than the fitness of the best chromosome so far, the one we declared earlier with fitness of 0 initially, if you remember, then make the best chromosome so far is our population, or make the best chromosome so far, let it become, or give it the value of the fittest member of the population so far, and then we evolve the population, and then we keep repeating. We saw this evolve population method before. Where is it? Yes, we've seen it before in the previous videos, right? So if we found the solution, then that's fine, we display. If not, at least we have the best chromosome so far, and this is the display method, which gives us, just displays the results basically. So after how many tournaments, dashing from our one line are, and then we just print out the coordinates of the dashes. And here, this is the as a list method we said we used before to transform the array into a list. We explained this in the previous videos when we spoke about finding the fitness. This is the fitness function or fitness method eval solution. We do 9 comparisons because we have 10 elements, as we explained before. I'm not going to repeat this. This is the order 1 crossover method that we again saw before, and this is just a method, simple method to print out the population. So enough talking, let's have a look at how this program works. Remember, the link to the code, you will find it below this video. Let's run it. As you can see here, it's printing out tournament number. We've not found the solution yet. We set it to be 3000, so it'll take some time to finish. Where is evolve population method? I'd like to show you which crossover method, which mutation method we're using. So we're using order 1 crossover, that's what we implemented, but in the mutation we do randomness here, as we mentioned before. We use currently scramble mutation, so it has actually reached to 3000 times, but it hasn't found the solution. We can run it again, or maybe we should print out the best solution so far. Sorry, I paused the video. What I did here is I went back to the main method and I added this simple check to check whether the solution was found or not. If not, then we can at least print out the fitness of the best solution so far, and that's by doing eval solution for the best chromosome so far. Remember, in the runGA method, we keep track of the best solution so far, right? The best chromosome so far is the same as the best solution so far. So if we found the solution, then the method display will display the results. Otherwise, we do all the tournament numbers, the maximum number of tournaments, and then we print out the fitness of the best solutions so far, right? So this is maybe what you want to do when you try to do the traveling salesman problem. You want the best or the lowest or the shortest distance so far. I'm sorry, where's my main method? There you go. So let's run this again quickly, and it will give us, if we find the solution, that's fine. If not, then we should get at least the fitness of the best solution so far, right? 3000 times. This is the maximum number of tournaments. It's going to repeat. Let's wait a few seconds. Maybe I should pause the video again here. It's still trying. No solution found yet. So if you repeat this several times, it will find the solution. But as you can see here, the fitness of the best solution so far is 8. So you can print out maybe the contents of that solution, or maybe let's say you want to change the mutation method. So we did scramble mutation. Let's do, for example, swap mutation and see what happens. You pause the video. Right, I paused the video and it didn't find a solution yet. So let's, for example, do, instead of swap, insert mutation. Maybe we should have implemented another crossover method, but let's try again. Execute again. Let me pause the video again. Right, I paused the video. You can see it's still trying. No solution is found. The best solution, the fitness for the best solution so far is 8. As you can see, if you repeat this several times, it will find the solution with fitness 8, which is the perfect solution. Otherwise, at least we keep track of the best solution so far. So I'm going to stop here. This is the end of this series. I hope you've enjoyed it. Remember, the link to the slides and to the source code will be below these videos. Thank you very much for watching, and I hope to see you in another tutorial.